Hi, I'm Arman Hafizi, a Master of Mathematics student at University of Waterloo. In this video, we demonstrate input methods and tasks for our experiment comparing gesture input for in-vehicle commands. This work is done with the collaboration of J. Henderson, Ali Neshati, Zhou, Edward Lank, and Daniel Vogel. The automotive industry is progressively moving to centralize the display and control of vehicle systems on a single console screen. Originally for infotainment like music and navigation, these are now frequently used for features like cabin climate control and vehicle status, and increasingly even for critical functions like windshield wiper speed. An ideal in-car infotainment system must prioritize accuracy, speed with regard to safety. Likely due to familiarity and the manufacturing economy, a touchscreen is commonly used for primary input, but this means the driver has to momentarily direct their visual focus away from the roadway. Speech control can be slow and unreliable, especially in loud environments, and it can disturb passengers. Steering wheel buttons increase manufacturing complexity and cost, and they're typically reserved for dedicated vehicle functions like cruise control. Midair gestures are already used in some high-end vehicles, but they're physically demanding. The performance of Midair gestures compared to conventional touchscreen input has only been evaluated in limited forms and higher-level tasks. The picture on the left shows a sample set of Midair gestures used in previous research that are complex and dynamic. On the right side is shown a sample song selection task that is relatively long and multi-step. The previous work clearly lacks a direct comparison of input methods with short duration atomic tasks. On the other hand, our work compares input methods including touch tapping, touch swiping, and Midair directional gestures with an atomic selection task. Furthermore, this allows us to directly compare each direction across all input methods to have a fairer evaluation. The experiment used OpenDS driving simulator with a gaming steering wheel, pedals, and an ultra-wide monitor. A touch tablet served as the vehicle center console, and a Vicon tracked the position of the index finger and thumb for Midair gestures. A 4K webcam captured off-road glances. Input method included touch tapping, touch swiping, and Midair directional gestures. The touch tapping baseline simply registered a touch on a target display on the tablet. The touch swiping method used the direction of a quick drag on the blank tablet touchscreen. The Midair input method used the thumb and finger pinch to start the gesture, then registered the direction when hand moved more than a certain threshold away from the starting position. All input methods were performed in 8 directions using prompts like up, right, and right. The pilot test showed it was easier to perform the 4 cardinal up, down, and left, right directions, so we use a non-uniform division of the circular space. This non-uniform division is further supported by work finding different gesture movement directions do not share the same accuracy. During the experiment, the participant performed a long-duration driving task while responding to prompts to complete input tasks as quickly as possible. The standard lane change task was used for driving. The participant maintained a target speed of 80 km per hour as they drove along a perfectly straight 3-lane roadway in a featureless landscape. At controlled intervals, 2 identical signs on both sides of the road appeared to signal a lane change was required. As the participants drove, a spoken audio prompt was played every few seconds indicating an input action direction. The participant used the assigned input method to perform the input in the prompted direction, and they heard a beep to confirm an input action was recognized. No feedback on correctness was provided. We designed a within-subject experiment with input methods as the primary independent variable and block and directions as the secondary independent variables, with 2 blocks per method and 8 directions per block. For the driving task, we calculated standard deviation of lateral position or SDLP and speed. For the input task, we recorded completion time as the sum of response time and selection time and accuracy. To evaluate distraction, the number of off-screen glances were captured. We also used the NASA TLX score as a subjective measure. The result of time measures indicate Midair was faster than swipe and tap. The light color indicates the response time, and the dark color indicates the selection time. Note that the selection time or dark part for tap is 0. Tap was 11% faster than swipe. Swipe was the slowest among all. And Midair was 22% faster than swipe and 13% faster than tap. The results of accuracy indicate Midair was less accurate than swipe and tap. Tap was the most accurate with 98%. Swipe was the next accurate with 95%. And Midair was the least accurate with 82%. There was no significant difference found for SDLP and speed across input methods. The eye tracking data showed that Midair was the least distracting among all methods. Tap was the most distracting with an average of 10 off-road glances during a block. Swipe was next with an average of 6. And Midair was the least distracting with an average of 3 across all methods. We also analyzed the NASA TLX score and no significant difference was found across methods, except for physical demand, with Midair being more physically demanding than tap. We found that participants performed Midair with a greater degree of variation compared to tap or swipe. The resulting plot confirms that the performance space for tap and swipe is relatively smaller, that is more consistent than that of Midair, highlighting how tap is more accurate and swipe is faster. On the other hand, Midair gestures carry a wider range of performance with more density for lower response time. By investigating potential causes of this performance diversity, it may be possible to identify ways to improve Midair gestures in order to interact with in-vehicle center console systems with the least amount of distraction. To investigate performance diversity within Midair input, we clustered the normalized error rate and response time points representing the 18 participants. The results show how participants can be classified into 3 clusters based on their performance. The green participants were accurate and fast, the blue participants were accurate but slow, and the red participants were neither accurate nor fast. In the experiment, participants performed 8 Midair directional gestures, with an overall accuracy of 82% across all directions. However, if the data is restricted to the 3 groups of gestures, the 4 main directions, right, left, up, down, then the accuracy improves to 98%, which is similar to tap and swipe techniques. Let's look at possible application scenarios for input methods. First, there's natural mapping to circular pie menu interfaces. The in-vehicle system commands triggered by such a pie menu could be contextual based on the system's state. For example, when there is an incoming call, the menu items could be answer, reject, mute, and callback. Another appropriate interface for directional input is a linear menu. A large number of menu items can be scrolled through using up and down directional gestures, with a right gesture to select the current item and a left gesture to go back to a previous level or dismiss the menu. Our study and the examples above are specific to in-vehicle systems, but the general style of directional gestures and associated menu interfaces could be used in other settings, such as controlling a smart television when seated on a sofa. However, a vehicle cabin has the advantage of a very stable configuration that is a very specific seated user location, a well-defined space for tracking Midair gestures, and a nearby touch surface. To sum it up, going back to our main motivation, our work showed that Midair directional gestures for an in-vehicle environment satisfy the 3 goals of accuracy, speed, and safety. Before I finish, I'd like to mention Edward Lank. Fortunately, it passed away last year. He was my supervisor, and I have to say that this work could not be done without his constant support and advice. I'd like to take this time here and remember and thank him. That was in-vehicle performance and distraction for Midair and touch directional gestures. Thank you for watching.